Welcome to e-content developed by Department of Collegiate and Technical Education. In this video, we are going to discuss session 3 of Unit 6 LPC2148 peripherals, that is Gpio resistors. In the previous session, we studied Gpio features, Gpio applications, Gpio pin description, and the types of Gpio resistors. So let's have a quick recall on the previous session. The Gpio features, there are 48 pins on LPC2148 which are going to use as Gpio pins, that is from port 0.0 to port 0.31 and port 0.16 to port 0.31. Total 48 pins. Those 48 pins has been divided into two ports, that is port 0 and port 1. Those pins are called as the Gpio pins, and all Gpio pins are bidirectional. That means we can use Gpio pins input as well as output pins. And next is we can read the entire port value, or we can write the entire port value in a single instruction, and we can set individual bits, or we can set individual bits by using the Gpio resistors. And all Gpio pins on default or by default acts as the input pins. Next is Gpio applications. We are going to use these Gpio pins to control the off-chip peripherals. All the off-chip peripherals are connected to LPC2148 through this Gpio pins, and also we can use driving the LEDs or to sense the digital input data, and in overall we can say that to control all off-chip devices we are going to use the Gpio pins. And next is Gpio pin description. There are 48 pins. In port 0, 32 pins, and port 1's 16 pins are used as the Gpio pins, that is from port 0.0 to 0.31 and port 1.16 to port 1.31 pins. And next, Gpio resistors. There are two group of Gpio resistors, that is legacy group of resistors and enhanced feature resistor. In this session, we are going to discuss the Gpio resistors, legacy Gpio resistors. There are 4 legacy Gpio resistors and enhanced feature Gpio resistors and examples. So, how to use this Gpio resistor to control the direction of pins, or to set the value on that pin, or to clear value on the port pins. And finally, let's discuss some of the assessment questions based on the topics that are covered in this video. So first is the resistor description. There are 5 enhanced Gpio features resistors and 4 legacy Gpio resistor. This enhanced Gpio resistors operation is faster than the legacy Gpio resistors. So first one is the legacy Gpio resistors. There are 4 resistors, that is IO DIR, IO pin, IO set and IO clear. And next, in enhanced features Gpio resistors, we have 5 resistors, that is fast IO DIR, fast IO mask, fast IO pin, fast IO set and fast IO clear. The first one is the IO DIR in legacy Gpio resistor, that is Gpio port direction control resistor. This is a 32-bit wide resistor because here the port 0 pins are 32-bit pins. To control the entire port pins, we need a 32-bit resistor. Therefore, all legacy group of resistors and enhanced feature resistors are 32-bit wide resistor. So this IO DIR is used to control the direction of port pins. In port 0 and in port 1 pins, directions are controlled by the IO DIR. On default, all pins acts as the input pins. If you want to set any pin on the port as output pin, we have to configure 1 on the corresponding pin. That is, setting a bit to 1 configures the corresponding pin as an output pin. Setting 0 configures the corresponding pin as an input pin. By default, all pins acts as the input pins. If you want to use any pin as output pin, you have to configure a binary value 1 on that pin by using the IODIR resistor. We can set entire port as an output port, or we can set individual pins on that port as output port by using the IODIR resistors. In LPC2148, we have two ports, that is port 0 and port 1. Therefore, IODIR, there are two IODIR resistors to control both port 0 and port 1. Here IO0 DIR controls the direction of port 0 pins and IO1 DIR controls the direction of port 1 pins. So IODIR is used to control the direction of port pins. Individually, we can set the direction of port pins, or the entire port can be set as input port or output port. If we are setting 1 on that pin by using IODIR, the pin acts as the output pin. If we set 0 on the pin by using the IODIR, that pin acts as the input pin. Let's look into one example. Here we are going to configure port 0 to 3rd pin as input pins and port 0's 4 to 7 pin as output pins. So this is with respect to port 0. Port 0 is a 32-bit port. So to set the 32-bit values, or to set the 32-bit pins, we need a 32-bit value. That is, this is a 32-bit value. Each digit takes the 4 bits. That is 32-bit value. Divide 4 bits each. Each bit is represent single digit, single hexadecimal value. If we convert 32-bit binary value into 4-bit each digit, then we obtain 8-digit hexadecimal value. So this is an 8-digit hexadecimal value or 32-bit binary value. So here the first digit represents the bits from 0 to 3 and the next digit represents the value from 4 to 7. In the same way, the 8th digit represents the bit value from 28 to 31. What they are saying, we have to configure port 0 to 3rd pin as input pin. To set the pins as input pin, we have to set value 0 on that pin by using the IODIR resistor, or to configure the pins as output pins, we have to send value 1 on that pin by using the IODIR resistor. For 0 to 3, we have to set, or we have to configure those pins as input pins. That means for these pins, we have to send value 0 by using IODIR, that is 0 to 3, 4 zeros, that is 0, 0, 0, 0. If we convert that 40 into hexadecimal, the hexadecimal value will be 0. So here in the first digit value is 0, that will configure 0 to 3rd pin as input pin. In the same way, from 4 to 7 as output. To configure pin from 4 to 7, we have to set value 1 on that pin by using the IODIR resistor, that is from 4 to 7, that is the second digit. So all the pins from 4 to 7 has to configure as output. That means 4 ones, 1 1 1 1, that is 1 1 1 1 means that is the value, hexadecimal value is F. So to configure port 0 pins from 0 to 3 as input and 4 to 7 as output, the hexadecimal value we have to set on port pins by using the IO0 TIR resistor is 0x000000F0. Here only the pins from 4 to 7 are setting as output pins, remaining pins by default input pins, and the pins from 0 to 3 also explicitly we are saying acts as the input pins. Here we are using IO0 DIR because these pins are corresponding to port 0 pins. So that's why we are going to use the IO0 DIR. And the next resistor is IO pin, that is GPIO port pin value resistor. All these resistors are 32-bit wide resistors. This is also a 32-bit wide resistor. Here the IO pin resistor is used to read the current state of GPIO configured port pins regardless of pin direction. It can be an input pin or output pin. What is the current state of the pin, that is read by using the IO pin resistor. Whether it is an input pin or output pin, what is the value on the corresponding pin, whether it is set to 0 or set to 1, that all is read by the IO pin resistors of Gpio. There are two resistors obviously because there are two ports, that is port 0 and port 1. To read the status of port 0, we are going to use the IO0 pin resistor, and to read the status of port 1 pins, IO1 pin resistor is used. So IO pin resistor, 32-bit resistor, is used to read the status of the port pins regardless of the pin direction. If the pin can be an input pin or output pin, whatever it is, we are going to read what is the current status on that pin by using the IO pin resistor. And next is IO set, that is GPIO port output set resistor. So this is also a 32-bit wide resistor. This resistor is used to make pins of port high. If you want to send value or binary value 1 on any pin on the port, then we are going to use the IO set resistor. So this resistor is used to make the port pins high. Writing 1 to specific bit makes that pin high. If you want to send value high on the port pins, you have to write 1, that is the binary value 1 on the specified bit. Writing 0 has no effect. If you are sending 0 on pins by using IO set resistor, it doesn't mean anything. If we are sending 1 on port pins by using IO set, it will set that port pin value to high. Again, there are two resistors for both port 0 and port 1, that is IO0 set used to make port 0 pins high, and IO1 set used to make port 1 pins high. If you want to send logical value 1 to any external peripherals or to any off-chip devices, you have to send that value by using the IO set resist. For example, configure pin port 0.4 as output pin. Here individually we are setting single pin as output pin, then set that pin high and then send logical value 1 on that pin. That is, for that we have to use this instruction. First we have to configure. By default all pin acts as the input pin. Therefore first we have to configure the fourth pin of port 0 as output pin. Here the port 0, so we have to use the resistors that are associated with the port 0. Therefore IO0 DIR, because port 0, therefore we are taking IO0 DIR assignment operation 0x. Then we have to look into the which pin of port 0, fourth pin. That is, from LSB we have to go for the fourth position. This is from 0 to 3 and this is from 4 to 7. So 0 to 3 all zeros, 4 to 7 that is 0001. In the fourth position of 32-bit we have to set 1, that hexadecimal value will be equal to 1, that is 0001. the hexadecimal value will be equal to 1. That is the how we are setting the fourth pin of port 0 as output pin by using the IO0 DIR. This is one way. This is another way of setting the fourth pin of port 0 as output pin, that is 1 left shift 4 times. If you take the binary value 1, that is 0001, and left shift that 4 times, it will come to the fourth position, then that value will be equals to 1 0. Here just we are saying the fourth pin of port 0 is used as the output pin. Next we have to set that pin high. To set the any pin value high, we are going to use the IO set resistor. Here with respect to port 0, we are going to use IO0 set. Same pin has to be set as high. In the same position, we have to write the value 1. If you write 0, it doesn't have any effect on the port pin. If we set 1, the corresponding port pin will be set to high value. So here we are saying the port 0 fourth pin acts as the output pin, and by using the IO set, we are setting the fourth pin of port 0 high. The next resistor is IO Clear Resistor, that is GPIO port output Clear Resistor. This is also a 32-bit resistor. This is used to clear the port pin values. So this resistor is used to make the pins of port low, or it will clear the value on the port pin. Writing 1 to specific bit makes that pin low. If you are sending value 1 by using IO clear resistor, that value will clear the value on the port pins, or it will make that pin low. Writing 0 has no effect. If you are sending 0 to the port pins by using IO clear resistor, it doesn't make any difference on the port pins. If you are sending 1 on the port pins by using the IO clear resistor, then it will make the corresponding pin value to 0. There are two resistors, that is IO0 clear used to make port 0 pins low, and IO1 clear used to make port 1 pins low. For example, configure port 0.4 as output and then set that pin value to low. So first we have to make that pin as output pin by using the IO0 DIR resistor, because this is with respect to port 0, so we are using IO0 DIR. Port 0.4 means it is the fourth pin of port 0 starting from 0th pin 0, 1, 2, 3, 4. So this first digit with respect to 0 to 3 pins and the second digit with respect to 4 to 7. So 0 to 3, 0, because by default acts as the input pins. So fourth pin means we have to set value 0001 for the second digit. That hexadecimal equivalent value is 10. So we are sending the hexadecimal value 00000010 for IO0 DIR resistor. This will make the port 0.4 as an output port. Then we have to set logical 0 on port pin port 0.4. For that we have to use the IO0 CLR resistor to clear the value on the port 0.4 on the fourth position of port 0, or on the fourth bit of the IO0 CLR resistor. We have to send the value 1 to make the port 0.4 pin as low. So the hexadecimal equivalent value is 00000010. This first is for 0 to 3 and the next is for 4 to 7. Only 4 is 1, remaining 0. Therefore, the value is 0001. The hexadecimal equivalent value is 10. And next is enhanced feature GPIO resistors. This resistor has same as legacy group of resistors. Only the difference is the operation of enhanced feature GPIO resistors are much faster than the legacy group of resistors. In enhanced feature also we have 5 resistors: fast IO DIR, fast IO mask, fast IO set, fast IO clear, and fast IO pin resistor. In that, the first one is fast IO mask resistor, that is fast mask resistor for port. It controls the effect of fast resistor. In fast resistors, we have 5 resistors. Out of 5, the effect of 3 resistors, that is fast IO pin, fast IO set, and fast IO clear, takes on the port pins, or that effect of this operation is controlled by the FIO mask resistor. That is fast IO mask resistor controls the effect of fast IO pin, fast IO set, and fast IO clear resistor on the port pins. How it controls? Setting a bit to 0 configures the corresponding pin access to the fast resistor. If you want to control the port pins by using the fast resistors, these 3 fast resistors, first we have to set value 0 on port pin by using the FIO mask resistor. If you are not enable that port pin by using the FIO mask resistor on those pins, you can't use the fast resistors, that is FIO pin, FIO set, and FIO clear. If you want to use these resistor operation on port pins, before using this operation, you have to enable that, or you have to set a 0 on that pin by using the FIO mask resistor. Setting a bit to 1 configures the corresponding pin unaffected by fast resistors. If you are setting 1 on that pin by using FIO mask, then the effect of these resistors on the corresponding pins will not take effect. That means if you want to control the operation of port pins by using fast IO resistors, that is FIO pin, FIO set, and FIO clear resistors, before controlling you have to configure value 0 on port pin by using the FIO mask. Otherwise, the pins will not affect by the FIO pin, FIO set, and FIO clear resistors. There are 2 resistors for port 0, one resistor, and port 1 another resistor, that is FIO 0 mask and FIO 1 mask. Controls the effect of fast resistor on port 0 pins, and FIO mask controls the effect of fast resistor on port 1 pins. For FIO DIR, we can use directly. If you want to use these 3 resistors on port pins, before using these 3 resistors on port pins, first you have to configure value 0 on port pins by using FIO mask resistor. And next one is the FIO DIR. This is same as IO DIR. Just the difference is the operation is faster than the IO DIR resistor. This fast GPIO port direction control resistor is also a 32-bit resistor. This resistor individually controls the direction of each port pins. Setting 1 configures the port pin as output pins, and setting 0 configures the pins as input pins. Again, there are 2 resistors. FIO 0 DIR controls the direction of port 0 pins, and FIO 1 DIR controls the direction of port 1 pins. And next is FIO pin, same as IO pin resistor, that is used to read the status of the port pin values regardless of the direction of the port pins. But here, before using the FIO pin, we have to configure 0 on the port pins by using the FIO mask resistor. Fast port pin value resistor using FIO mask. So only bits enabled by zeros in FIO mask can be read. Otherwise, we can't use the FIO pin to read the status of the port pin values. For which pin you want to read the status of the port pins, first you have to configure those pins or we have to configure 0 on those pins by using the FIO mask resistor. There are two resistors. First one is FIO 0 pin and FIO 1 pin. FIO 0 pin reads the current state of port 0 pins and FIO mask 1 pin reads the current state of port 1 pin. And next is FIO set, that is fast port output set resistor using FIO mask. This is also same as IO set resistor, but the operation is faster than the IO set resistor. Again, before using the FIO set resistor on port pins, those port pins has to be configured to 0 by using FIO mask resistor. This resistor is used to make the pins of port high. Writing 0 to specific bit makes that pin high. If you want to set logic 1 on that pin, you have to set value 1 by using the FIO set resistor. Writing 0 has no effect. Only bits enabled by zeros in FIO mask can be altered. So before using FIO set on port pins, you have to configure value 0 on port pins by using the FIO mask resistor. There are two FIO set resistor. FIO 0 set used to make port 0 pins high and FIO 1 set used to make port 1 pins high. And last one is the FIO clear. This is used to set value low on the port pins. Again, for FIO clear also, before using FIO clear resistor, you have to configure value 0 on port pins by using the FIO mask resistor. So this is again a 32-bit resistor used to make the port pin values low. Writing 1 to specific bit makes that pin value low. Writing 0 has no effect. Again, only bits enabled by zeros in FIO mask can be altered. So if you want to low or if you want to set value low on any pins of the port, before using the FIO clear, you have to use FIO mask resistor to enable that pins to use the remaining fast resistors by configuring 0. There are two resistors, FIO 0 clear and FIO 1 clear. FIO 0 clear used to make port 0 pins low and FIO 1 clear used to make port 1 pins low. So this is all about the resistors of GPIO. There are two resistors. There are legacy group of resistors and enhanced feature resistor. Let's look into some of the assessment question. The first question, IO pin resistors of GPIO is used to. For what operation we are going to use the IO pin resistor of GPIO? There are four resistors, that is IO set, IO clear, IO pin and IO DIR. In that, IO pin is used for whether it is used to read the current status of the port pins or make the port pins value to high or make port pin value low or set the direction of port pins. What is the correct answer? It reads the current status of the port pins regardless of the pin direction. Pins can be input pins or output pins, whatever the pins are, to read what is the value on the port pin, whether it is a value 1 or value 0, that is read by the IO0 pin resistor or IO1 pin resistor. Next one, IO set resistor of GPIO is used to make port pins to high value. If you want to set that pin value to high, then we are going to use the IO set resistor of GPIO. And IO DIR resistor of GPIO is used to set the direction of port pins. IO DIR is used to set the direction of port pins. By using IO DIR, we can set the port pins as output pins as well as port pins as input pins. If we are sending value or we are configuring value 1 on port pins by using IO-DIR, those pins acts as the output pins. If we are configuring value 0 on port pins by using the IO-DIR, that makes those pins as input pins. Next is IO. Clear resistor of Gpio is used to make port pins to low value. Again, here also same, configuring 1 makes that port pin values to low, configuring 0 does not make any effect on the port pin values. Code to configure pin port 04 to port 07 as an output. What is the hexadecimal value we have to configure on port pins to make from port 04 pin to 7 pin as an output pin? To here we need to control the direction of port pins. To set these port pins direction, we are going to use the IO-DIR resistor or FIO-DIR resistor. So in all the 4 operation, we have the DIR operation. Next, we have to look into the which port, whether it is port 0 or port 1. Here, we are taking port 0. That means we have to look into the IO0 DIR. Here also IO-DIR, IO0 DIR, and in option C also we are having IO0 DIR. So either A or C. In that again we have to check which pins of port 0, that is 4 to 7. 4 to 7 means, so first position is 0 to 3 and second position is 4 to 7. So in A we have 0 to 3 0 and 4 to 7 1. We need 4 to 7 as output pins. So only on those position and only on those bits has to be made to 1, that is F0. In C we have 0F. This is wrong because 0 to 3 1 1 means this makes the 0 to 3rd pin of port 0 as output bits. But in question we have 4 to 7. Then the correct answer is A, that is 0 0 0 0 0 0. F0 has to be set on IO0 DIR resistor. The next question, code to configure pin 0.0 to 0.3 as output, then set those pins low. So first we have to set these pins as output pins, then set value low on those pins. So to control direction, we have to use DIR resistor, and to set to low on pins, we have to use the Clear resistor. So in all the option, we have both IO-DIR and IO-Clear. Then we have to look into the port. Which port? Port 0. Then we have to check whether we are using the 0th resistor. IO0 DIR, IO0 Clear. Here 1, so this is not the answer. Here also 1 is there, so this is not the answer. Either A or C. Check again A and C. IO0 DIR, IO0 DIR, IO0 Clear, IO0 Clear. Next we have to look into the port pins. That is 0 to 3. 0 to 3 means first digit. So first digit in for option A is 0. So first digit 0 means here 0 to 3 acting as input pins. So this is not the answer. In C, check the first digit. So first digit is F, that is 1111. That means if you are sending 1111 on 0 to 3, this will make that port pins as output pins. And next, set value low on those pins. So we are using IO0 Clear. Again the same pins and the same position we are sending the value 1111. Therefore the correct answer is C. Next question, code to configure pin 12 to 15 of port 0 as an output. Set those pins high. First is IO-DIR and next is IO set. In all the option we have in the first option we have IO-DIR and IO Clear. So this is not the answer. In second one IO-DIR, IO set. So this may be. In third IO-DIR, IO set. This may be. In last IO-DIR and IO Clear. So this is not the option. Now look into the B and C. So B and C, IO, DIR and IO set port 0. In both the options we have zeros, 0 resistors. So next look into the pins of port, that is from 12 to 15 as an output. So first position 0 to 3, second position 4 to 7, third position 8, 9, 10, 11, and fourth position is the 12, 13, 14, and 15. So at this digit we have to make all 1, that is 12, 13, 14, and 15. So this will make the port zeros 12 to 15 pin as output pins, that is IO0 DIR 0000 F000. Here are the same option? No. Then the answer will be C. So set in the same position, we have to use the F value. Thank you all my team members for their valuable guidelines for making this video.